Part D. Now this is serious. Find the area bound by the curves y equals x to the third minus 8x squared plus 16x plus 1 and y equals x plus 1. Oh my goodness. Okay, get ready. If you were to graph these two curves in Desmos, you'd get a little something like this. That x cubed function is pretty interesting. So it has this big arc and then it sweeps back down and then goes back up. While this line sort of cuts right through the center of it at that angle. So there it is. Now if we're thinking, okay, find the area of the region bound by the curves. We're thinking, well, I mean, they cross 3 times, right? So what is the area? And it turns out there's actually 2 areas. There's this, but then because it crosses, this part is still bound between them. Both of these areas have the 2 functions as their boundaries, right? There it's bound between, and then there it's bound between. Turns out we need to find both of these areas and then add them together. We're going to find them separately and then combine them. Okay. So let's call this area 1, A1, and this area 2, A2. Of course, we need to know, where do they cross? Well, here it's pretty clear they cross at 0 because they both go through 1 at that moment. Yes, they cross at 0. But the other 2 times, where does this occur? And where does this occur? Now, again, if that's really clear graphically, then just put those numbers in. You don't need any work. And by the way, on your test, you're going to be given access to Desmos for this test. No problem. You can graph these sort of things on the test. You're not going to have to know what that graph is. You're right. I don't allow graphing calculators because I can always, really what I would do if this was in class, I would just provide that sketch without the shading. But that's not the case. So you guys are going to get to use Desmos when you take the exam. Okay. What to do from here? All right, we got to find those 2 locations. Well, that's when the 2 equations are equal, right? X values where they cross. Set the equations equal. And solve for x. Now, I'm not going to spend a lot of time on this. Here we go. We're going to subtract everything to one side. Set it equal to 0. Turns out those 1's cancel out, and that's really nice. We've got x to the third minus 8x squared plus 15x equals 0. Then we're going to start to factor. We can take an x out of all 3. Okay. So once that x comes out, x squared minus 8x plus 15. Then turns out this factors again x minus 5, x minus 3. And we got our 3 x values. Well, looks like that's on the next page, but anticlimactic there. So 0, 5, and 3. Boom, boom, boom. Okay, I think I will go back to my sketch and put those in. So I knew 0 already, but then this is 3 and this is 5. 0, 3, 5. Okay, well, those came out pretty nice. That's good. All right, now the task is to find each area and we add them together. So we got to think, okay, so for area 1, I go from 0 to 3, and then what's on top and what's on bottom? So on top is my cubic, on bottom is the line. Okay, we're going to do that first. Then when we go to A2, notice they switch, right? Now the line's on top and the cubic is on bottom from 3 to 5. All right, anyway, we're going to start with A1. Here it is. So 0 to 3, the cubic on top minus the line on bottom. Top minus bottom. And again, at that point, we've really done, that's the new material here. Well, let's go ahead and simplify this. That's going to make our work quite a bit simpler, a little bit simpler. So distributing the negative, right, we end up with the 15x, and then the 1's cancel out. Hey, that looks familiar when we were solving, right? X to the third minus 8x squared plus 15x from 0 to 3 is the integral. Okay, let's go ahead and knock out the antiderivatives. So 1/4 x to the fourth minus 8 over 3 x to the third plus 15 over 2 x squared. Doing the antiderivatives, then we evaluate from 0 to 3. And, oh man, okay, so plugging in the 3's. Subtract, plug in the zeros. Now what's great, the zeros aren't, that's just all going to be 0. So when you grab your calculator, you just need to do the first half, since you're going to subtract 0. And if you do that, well, I got 63 over 4 for area 1. Okay, but we're only halfway there. We also need area 2. Area 2, if you remember from the graph, we go from 3 to 5. And now they've switched. The line is on top minus the cubic. X plus 1 minus, well, you see it right there. Very important. These have to switch. The line's on top, cubic's on bottom. Top minus bottom. Well, let's go ahead and simplify that. So I would have negative x to the third plus 8x squared minus 15x, and the 1's cancel. You notice that it's just the negative of the way we did it previously. Well, that makes sense. If you reverse the order, right, you subtract the other way, it's going to be the negative. So a negative, positive, negative for our terms here. So there's definitely a similarity. Well, doing the antiderivatives, negative 1/4 x to the fourth plus 8 over 3 x to the third minus 15 over 2x squared. And this time we go from 3 to 5. Okay, plug in the numbers. I'm probably going too fast. I wouldn't be going near this fast if we were in class. But because this is a video, you can pause it or replay. Okay, so we've got the 5's going in, 5, 5, 5. The 3's going in, 3, 3, 3. No such luck with a 0 this time. I think I just tell you the answer though. I believe when I actually did it, I did them separately. And then I subtracted those two because that was just over. I didn't want to go through that whole thing at once. That was too much. But this time, hey, 16 over 3 for area 2. So what is the final answer? Well, I'll just show you my final steps. So the total area, A equals A1 plus A2. So that's 63 over 4 plus 16 over 3. And in my calculator, I got that to be 253 over 12 as my final answer. Okay. Well, as far as finding the area of regions defined by curves, we've seen everything we need to see. But there is one type of application that I need to show you before we conclude this section. Let's go for it right now. It's called the Gini Index. Let me just show you the whole thing there. This is in the textbook, of course. But here it is. So the Gini Index, Gini. So you see the formula. Let me tell you what it actually is. Like, what does this measure? It measures income concentration in a population. So think like income diversity, sort of income distribution, if you will. The answer is always somewhere between 0 and 1. Think like a percentage. So if it's a 0, that means absolute equality. Everybody shares an equal income. Okay, income is perfectly distributed evenly. But as the Gini index gets closer to 1, then there's just what we call inequality. So absolute inequality, if you get all the way to 1, absolute inequality, that means that one person has all the income and everybody else has nothing. So that really doesn't happen. But I mean, you might get a Gini index of like 0.9, which would mean, 10% of the population, has everything. So I'm actually kind of speculating that means 10%, but a 0.9 would mean very few people have the vast majority of the income. Okay. So in the income distribution. All right, so what does the equation look like? Well, it looks like what we've been doing. So the Gini index equals, it's always 2 times the integral from 0 to 1, and you take x minus f of x. So what is f of x? F of x is called the Lorentz curve. That will be told to you in a problem. They got to tell you the Lorentz curve. In real life, the Lorentz curve is found by analyzing lots and lots of data. They come up with that function. Okay, so there's the Gini index. Let's do a problem. There's no graphing here. There's just that familiarity from the formula when you're subtracting. That's really the connection. So this is an interesting one from the U.S. Census. The Lorentz curve in 1962 was this. 1962 in the U.S., the Lorentz curve f of x equals 3 over 10x plus 7 over 10x squared. Let's find the Gini index. So what was the income distribution like in the U.S. at that time? Okay. Well, I mean, if we know the formula, then it's right there. We just take f of x and put it in. So Gini index equals 2 times 0 to 1 x minus f of x dx. So we just put that right on in. That's all there is to it. Don't have to graph anything. All right. Well, let's go ahead and simplify. So if we distribute x minus 3 over 10x would be 7 over 10x. And that negative is going to go there. So minus 7 over 10x squared. Okay. And all right, let's do the antiderivatives. So I'm just going to keep that 2 out front. 7 over 10x, well, it would have been x squared, and that needs to be a 20 so that when the 2 multiplies, it goes back to a 10. So 7 over 20x squared. And this one, well, it would have come from a cube, so that's got to be 30. So when we multiply by 3, that cancels, gives you a 10. 7 over 30, x to the third. From 0 to 1. Now, what's really nice about the Gini index, it's always 0 to 1. So the 0 is great. The 1, not far behind. Plug in the 1. Subtract, plug in the 0. And we're going to get it. Well, all of this just goes to nothing, right? And then even the 1. So what is it? Like, well, yeah, 7 over 20 minus 7 over 30. Looks like I showed that step. And then what does that work out to be? 7 over 30 when you compute this. But really, it's more helpful to have the decimal form for the Gini index. So I rounded it 0.23. Which, if you think about it, you know, Gini index of 0.2, that's definitely on the low end. I'm not an economist. I don't know if just how good or how not good 0.23 is, but you know, that's getting down close to zero. So income is fairly well spread out. I think I don't know. All right, that is it for 6.1. That's it for integrals for us. Good luck in the homework. See you in the live session.